Here are some examples of naming aldehydes and ketones, and I want to go through these because I can't find it in the UCI lectures. When she started aldehydes and ketones, she said that she was going to do it in the next chapter, and I've been unable to locate it, so I figured it was, in the end, going to be faster and more efficient for me just to do it. If you can name alcohols, you can name aldehydes and ketones. In fact, if you can name alcohols, you can name most anything. So what we're going to do here is we're going to take for aldehydes, take the hydrocarbon name that ends in E and replace that with Al. So be sure that your A is distinct from your O that you would use for an alcohol name. So E to Al. Cyclic aldehydes are a little bit of a different story, and we'll deal with that example when we get to it. For ketones, you drop the E of the hydrocarbon name and you replace it with -one. For aldehydes, since the aldehyde carbonyl is always at the end of the chain, you don't specify the number because the number would always be 1. Ketones, on the other hand, can arise within a chain. In fact, they are going to arise within a chain if they're ketones, and so therefore you have to specify their location within the chain. And just as we did with alcohols, you use whatever numbering system you use for the chain to specify the substituents. So let's start with this aldehyde, and the first thing we want to do is identify the parent chain. So that gives us the parent chain, and then we can number the parent chain. So the aldehyde is 1, 2, 3, 4, 5, for the methyl group 6. So this name becomes 5-methyl-hexanal. So now looking at the second one, our parent chain is there. And notice in the first example that I included the H, and in the second example I didn't, just to show you that yes, it's possible not to show that particular H. Students are often more comfortable if they include the H. And again, we can number the chain 1, 2, 3, 4, 5. So this would be a 4-methyl pentene, so we're going to drop the E and replace it with Al. So we have 4-methyl 3-pentene al. Specify when you do the double bond, you always specify the location of the first occurring double bond carbon first. For this next one, first we find the parent chain. Find the parent chain, which is this, which sometimes annoys students a little bit because they think that the parent chain should be the longest chain. But remember that the parent chain is the longest chain that includes the main functional group. So we'll go 1, 2, 3, 4, 5. Doesn't matter whether we do that or we go off to the right in this particular case, same number of carbons. So now we have 2 propyl pentan al. So not so bad. Aldehyde or cyclic aldehydes present an interesting challenge because typically when we name compounds, we make the carbonyl carbon part of, well, let's see, we make the ring the parent, which, you know, is what we'll be able to do down in number 6 with that ketone. But we can't do that here. And so the parent is kind of that whole thing, and it gets a special name. And the special name that we use for aldehydes that are cyclic, that have the aldehyde carbonyl is right attached to the ring, are cycloalkane carbaldehydes. I did not invent this system, don't blame me. So if we number around the chain, around the ring, we have 1, 2, 3. So you have 3, 3, dichloro, and then we have cyclobutane carbaldehyde. And in the ring, the number 1 carbon is always the one that's attached to the aldehyde. And so this is what you're going to do in any situation where you have the aldehyde carbonyl directly attached to the ring. If you don't, then there are other things you can do, and I'll actually demonstrate that a little bit lower. So that's aldehydes, at least for now. So now we'll tackle this ketone. And first thing we need to do is find the parent chain, which is the longest continuous chain that includes the functional group. I never know if I should include the oxygen or not, so I did. And we're going to number to give the main functional group the lower or lowest possible number. And so that's going to go up like that a little bit awkwardly. And so we have a methyl group on carbon 4, so we have 4 methyl. Now we have to specify the location of the ketone because it could be kind of anywhere. And so that becomes 2 hexanone. Cyclic ketones, unlike cyclic aldehydes, are no problem. And the reason they're no problem is because the carbonyl carbon is part of the ring. So it's just going to be the same thing we would do in this situation for a cyclic alcohol. So we're going to number around the ring 1, 2, 3. And so that's going to give us 3, oops, that should be a comma between those. 3, 3, dimethyl cyclopentanone. So much easier than the aldehyde situation. Then moving on to the next one. Every time I do one of these things, my cat appears and sits on my arm without fail. And here we go. All right, so here, our longest chain that includes the functional group is that. And we're going to number to give that ketone carbonyl the lower possible number. So 1, 2, 3, 4, 5, 6. And now we need to figure out what we need to call this group. And that's a methoxy group. So this name becomes 5-methoxy 3-hexanone. And in several of these examples that have chiral carbons, I haven't specified the configuration of the chiral carbon in my structure, which means you wouldn't need to include it in your name. That would include number 4 and number 5 and also this one because of the configuration of the methoxy. So continuing on to this compound, we find the longest continuous carbon chain, which is that. Doesn't matter whether we number from the right or from the left because we're going to get the same thing no matter what. And so what we have here is 2,4 dimethyl 3-pentanone. There is an older naming system whereby you name the alkyl groups that are on either side of the ketone and then just put ketone at the end. So this then becomes diisopropyl ketone, sort of like naming an ether. You're not responsible for this naming, but I thought I'd mention it in case it comes up. So with this compound, we're going to name the phenyl as a substituent. So this becomes our parent. And we have 1, 2, 3. And the double bond is E, so we need to specify that. So we can stick that in front of the whole mess. And then we have 3-phenyl, which is the substituent name for a benzene ring, 2-propene-al. And again, we don't need a number for the aldehyde. And this particular compound, may look familiar to those of you who took Chem 21 at SMC. Not quite this compound, but the equivalent carboxylic acid is the compound that we used when we brominated. So sometimes students ask, what do you do if you have 2 ketones? So what we're going to do here is pick a nice color. And so we have this cyclopentyl ring. And so in this particular case, we use the name of the name that you would use if it was a hydrocarbon, complete with the E, and then just stick dione at the end of it. So 1, 2, 3. So you have 1, 3, cyclo